So this is the Arduino programming on-ramp. We're going to be using a button LED wing from the Gadget Factory. The button LED wing has 4 LEDs on it and 4 switches or buttons. So why are we using it? Seems sort of stupid, we'll never see it in a project. Well, the LEDs are outputs. They represent motors and sound and every other type of output. The switches represent sensors. Sensors could be a CO2 sensor. Fundamentally, all circuits have inputs and outputs. Arduinos are really good at dealing with the physical world. They're at the right price point. The software creation's easy, the hardware's cheap, but the hardware's pretty sophisticated and the software's pretty sophisticated. Competing with the Arduino is the PIC world. It's a little bit cheaper, a little bit less functionality. Software's a little bit harder to use, so it's widely used mass-produced devices. There's over 1 billion PICs sold yearly. So you're going to find little tiny PICs on a garbage can that are detecting the level of garbage in it and signaling a garbage truck to come by and pick it up. That's the Internet of Things. So you're going to be living in a world where writing little tiny programs that don't normally run in front of a human being are going to be commonplace. So why not write in Python? Well, Python can't run on an Arduino. The CPU's too primitive. It's not designed to talk to a monitor. So if we look at this, layers of software here, software that runs in front of a human is very complicated and requires a computer. And then there's libraries associated with it that are evolving that make it even more complicated. And all of this runs on top of an operating system. And you need tools to develop the software. So we use an IDE that runs on a full-blown computer up here, and then we send it down a USB cable into the Arduino. So the Arduino doesn't even have a keyboard. It doesn't even have a mouse. And this is typically how you write drivers. Drivers are those things that you see when you plug in something new into a USB port, and a little window pops up and said, I'm finding the driver for this thing. There's even more primitive world called FPGA programming, and the dominant languages there are VHDL and Verilog. And then we can, of course, physically wire up chips. So if you want to have a summary, Python's like our body, and Arduino and C programming are like the microbes in our stomachs. Are there some other alternatives? Yeah, there are. Most everything you do with an Arduino, you could do the entire thing in hardware. No software at all. But once you get down into designing hardware, it gets more expensive. It's harder to design. It's simpler to write software. So it's a price point issue. If it's harder to design in hardware, but you're going to mass produce it and sell it at Walmart, then of course do it in hardware. You're not going to do it with an Arduino. The Arduinos start off at around 30 bucks. The other way you could do it is have a bunch of little tiny Arduinos, like PICs, and then have a remote control, and then have the user provide all the logic. The user just turns things off and on, just by a 9-channel remote. Okay, so here's our challenge. This is a button LED wing. These are holes right here that you plug into a breadboard. So number 2, this is where a push button is connected. These are the push buttons right here. So push button 1, push button 2, push button 3, push button 4. So these are the pins the push buttons are connected to. The LEDs are connected, this pin right here, this one, and this one. Those are the LED pins. Now these 4 right here are associated with power. So what we see right here are these pull-down resistors that make sure that when these switches are up, that the Arduino knows they're up. And then over here, these resistors are protecting the 4 LEDs. So here we see the Fritzing schematic. This blue wire goes to pin 1. And yeah, pin 1 will work, but the coding gets a little bit more complicated because these 2 pins are used for serial communication, so it's better to run this one over to pin 13. Otherwise, everything else is pretty much the same. The button wing has this header. You want to spread the header over the trough like this. So you have most of the pins, these first row of pins over here on the edge closest to the Arduino. These are the two power lines. This is the positive and this is the negative. So the next step is to go look for code for the button LED wing. But the problem is there's none on the internet for it. The button LED wing was designed for a Papilio, which is open source hardware, sort of like the Arduino, but a totally different world, and the hardware that's added to it are called wings. So this is one open source standard. There's another one that's called PMODs. We have some of these. For the Arduino, you stack these circuit boards on top of each other. The Arduino's on the bottom, and then stacked on top of it are shields. And these things right here are called headers. So the problem is that we're not going to find code for an Arduino to talk to a wing. They're not designed to. So this is not a normal combination. So we've got to make one up. So here's the sample test code. Actually, these next 3 slides are the sample test code. So here we define our variables. They're all integers. And you can see I've connected switch 4 to pin 13, not to pin 1. Here we can see the setup code. This is where we tell the CPU, the Amtel CPU on the Arduino, we tell it that LED 1 is an output. So we're telling that pin right here that's an output pin. Similarly, these switch 1's pin is an input pin. That's it. The loop, which is done over and over and over again, looks for these switches being pressed, and if they're pressed, makes the corresponding LED high. And if it's not pressed, then it makes it low. So you can see the pattern here: high, high, low, high, high, low, high, high, low, high, high, low. And then there's 4 of these loops right here, these if-then else commands. The 4 are for the 4 switches right here, or buttons. Okay, so here's the assignment. When switch 1 is pressed, the even LEDs come on, then they go off, then the odd LEDs go on, then they go off, then the even LEDs come on, then they go off, and it keeps repeating until you let go of the switch. When switch 2 is pressed, the LEDs go on one at a time, in sequence, left to right, then right to left to right, right to left, over and over again until you let go of the switch. When switch 3 is pressed, the outside ones go on, then the inside ones go on, then off, then the inside ones go on. So you get both ends moving in and out in sort of an advertisement kind of a pattern. And then your 4th challenge is to just create something different. In doing so, you need to create at least 2 new functions, and here's a video of describing what 1, 2, and 3 look like. That's it.